Hello, 6th grade. This is your first set of video review notes. These are notes that you can watch to help you review for the upcoming test, but it shouldn't be the only thing that you use. You should definitely review on your own, use your foldable, look over your notes, create review sheets, look over the review sheet I gave you. These notes, this video is more just a backup in case you, a part of your notes you didn't understand or a little part you wanted a little refresher, or if there was some sections of your notes that are missing, that's what these are for. So I'm going to quickly go over the pages of our notes for you. So we started off this unit, the rocks and mineral unit. We had some big questions to start us off here, and won't go over all of these, but really we looked at different ideas of what are minerals and how do they relate to rocks and why are we studying these. So move here, there's some of the homework. Make sure you look over your homework. Look over graded homework. There might be a question on the test that you've already had on a homework, so it's really good to look over your homework. We first started off by looking at both rocks and minerals and seeing if we could sort of understand the difference between the two. And we realized that minerals mostly seem to sometimes let light through them. Not all rocks get to do that. Sometimes minerals seem a bit more shiny. They can reflect light. Rocks don't do that as often. Sometimes we saw that minerals have sort of nice smooth edges. Sometimes rocks do, but not always. And then a lot of times rocks have multiple colors, whereas minerals usually just have one or maybe two colors. And we sort of saw that. So that's one way to get thinking of the two different aspects there. All right, so first going into minerals. There are 5 characteristics that all minerals have. All minerals have these 5 things. They are inorganic. They don't come from living things. They come from non-living things. They are solid. You have to be solid to be a mineral. They have to occur naturally in nature. You can't make them in a laboratory. Minerals occur naturally. They have a unique crystal structure. They're structured in unique ways, and that's due to the fact that they have a unique chemical composition. They're made up of unique combinations of chemicals. So every mineral you have has a unique chemical composition, a unique crystal structure. It occurs naturally, it's solid, and it's inorganic. Another thing about think about unique crystal structure, we talked about this briefly, is that the unique elements that are in a mineral, for instance, pyrite is a mineral and has these elements, iron and sulfur, and those iron and sulfur atoms are arranged in a unique way that makes pyrite, when it grows into a cube shape. So it's the structure of those elements put together to create a unique shape, and that's why pyrite is always growing in these sort of cube-type crystals. It gives it a gold color, but remember, pyrite is not made out of gold. Gold is an element. Pyrite is really just iron and sulfur. And actually, when we think about the streak test coming up, that'll make a little bit more sense. We talked briefly about how minerals are used in everyday life. You don't really need to know this for the quiz. Here's some basic examples where minerals are used, but they are used in lots of different ways throughout. We didn't use this page. Don't worry about this page. The connection between minerals and rocks is that minerals make up rocks, but rocks don't make up minerals. So as we look at minerals, think that these are the building blocks of rocks. Rocks are made up of different types of minerals. Now, to identify one mineral from another mineral, there are 8 different properties that we need to think about. One is hardness. Certain minerals are harder than others. And so when we did our hardness activity, we saw that talc is not as hard as calcite. Calcite could scratch talc. So using, and you'll have to do this for the quiz, using the scale of hardness and some of the other things at your disposal, like a nail, which is basically made out of steel, or your fingernail, you can figure out which minerals are harder than other minerals. We saw that quartz was able to scratch feldspar, but feldspar can't scratch quartz. So that quartz is a little bit harder than feldspar. The hardest mineral is diamond. There's no mineral that can scratch a diamond. Diamond is the hardest mineral, so that's pretty cool. So that's hardness. There is luster. Luster is quite simply, how do minerals reflect light? If it reflects light well, it's kind of shiny and it kind of looks like metal, and we call those minerals metallic. Pyrite is a metallic mineral. It kind of shines. Other minerals that aren't so shiny, they can be sort of dull or glassy or silky. Those are called non-metallic. Kaolinite is a non-metallic mineral. We looked up there, talc is a non-metallic. Quartz, non-metallic. So that's luster. Luster is another property. Color. Some minerals, color isn't a great property to describe minerals because sometimes the same mineral can have different colors, like quartz. It has to do with that, though all of these minerals are quartz, sometimes the mineral might have a few extra little drops of chemicals, so to speak. And those extra few chemicals give it a special color. So you can have different colors of the same mineral. So color is a property, but it's not always the best property to identify a mineral. Another property is the crystal systems. You will not have to memorize crystal systems, but just know that different minerals have different crystal systems. Some minerals grow in cubes, like pyrite. Some grow in sort of a hexagonal shape, like quartz. Quartz is hexagonal. Garnet grows in a cubic shape. We'll see some more garnets later on when we go on our geology hike a little bit later on. I'll tell you more about that later. But anyways, keep in mind crystal systems, another way to distinguish one mineral from another. Streak. If you take a mineral and you scratch it on a tile here, if it's not as hard as the tile, then it will sort of break apart and you will get to see it's the powder that the mineral breaks apart in. That's called its streak. Streak's another way to identify minerals. A good example of streak is pyrite. When you scratch pyrite, it doesn't scratch gold. It might seem gold when you're holding it, but when you scratch it, it becomes a brownish black color. That's the streak of pyrite. Sulfur had a yellow streak. Galena had a kind of gray and silver streak, and good old graphite that we use in pencils leaves a gray, black, looks like a pencil mark streak. That's graphite, the mineral. Density. Density is another way to tell different minerals from one another. Density has to do with if you hold two different types of minerals, if one seems heavier than the other, it's more dense. The galena is more dense than quartz. As you held both of them, whoa, galena seemed pretty heavy. That has to do with the elements that are in the mineral galena. Galena has lead in it. Lead is a heavy element. You'll learn more about elements in 8th grade, but that's why galena is more dense and it feels heavier. So density is another one. Cleavage or fracture. When a mineral breaks apart, does it break apart in nice cleaved ways, like with the straight sides, or does it fracture apart and leave kind of a jagged edge? When quartz breaks apart, it's a fracture. It kind of breaks apart into pieces like that. But like mica, when mica breaks apart, it breaks apart nicely in these smooth edges, and so that's another way to distinguish between the two minerals. And then lastly, there's a couple special properties. Some minerals are magnetic. Some glow with ultraviolet light. We didn't get to see those, but that's another one. Calcite, some of you might be able to see this. Calcite can split, it's called diffraction, light underneath it. So if you look at a word through calcite, it looks like there's two images. That's pretty cool. So there's a couple other special properties as well. So those are the properties. As a quick review, 5 characteristics that all minerals display, and then 8 properties that distinguish one mineral from another. Make sure you know the difference between the 5 characteristics and the 8 properties. Okay, now on to rocks. Let me make this a little bit bigger so we can see it here. There are 3 different types of rocks: igneous, metamorphic, and sedimentary. The first one, igneous rocks, are rocks that form from the cooling of lava or magma. And where that magma cools and how fast it cools determines the kind of rocks you get. Rocks that cool inside, deep inside the earth or inside the belly of a volcano, those types of rocks cool slowly. Because they cool slowly, crystals are allowed to grow larger. We call those intrusive igneous rocks. They form inside a volcano, cooling slowly, allowing minerals to grow large. The other type is when lava comes outside, or magma comes outside and becomes lava, comes down, and it cools quickly. Kind of like wax falling down the outside of a candle. Because it cools quickly, it doesn't allow minerals to grow. Maybe you have little ones grow a little bit, but not really. They don't really get to grow that much. They cool quickly. Those are called extrusive igneous rocks. Examples of intrusive igneous rocks are like granite and pegmatite. We saw examples of those in class. Examples of extrusive igneous rocks include scoria, obsidian, sometimes known as volcanic glass, tuff, which is a type of volcanic ash, or even basalt, which is the most common rock we find on the surface of the earth, most of which is underneath the ocean. So that's igneous rocks. The next time, we'll do metamorphic. In class we did sedimentary and then metamorphic, but let's do metamorphic. Metamorphic has to do with rocks that change form. They metamorphosize, all right? And there's 2 things that make a metamorphic rock form, is heat and pressure. And that causes 2 types of metamorphic rocks. One is called foliated. That's where when the pressure and heat happens and the minerals all line up in a sort of a line pattern, and you can see bands or lines in the rocks. That's called a foliated metamorphic rock. But sometimes there are no lines, and those are called non-foliated rocks. So for example, sandstone, if squished under heat and pressure, can create something called quartzite, a type of metamorphic rock. Quartzite is a non-foliated metamorphic rock. You don't see any lines in quartzite. As opposed to both schist and gneiss, those 2 forming from other types of rock, igneous rocks in this case, create new metamorphic rocks that, yes, you do see the lines banded up there. So that's another type of foliated metamorphic rock. Marble comes from limestone. Marble is non-foliated, though very pretty and made into all sorts of neat statues. It usually does not have lines in it, so it's a non-foliated metamorphic rock. Then we have sedimentary rocks. Sedimentary rocks come from sediments. Sediments are small pieces of other rock, minerals, shells, even just chemicals. Sometimes you can think of as these small little pieces that get broken apart, get washed away, get compacted and cemented together. So these steps are very critical in creating sedimentary rock. First, there is weathering and erosion. Bigger rocks are broken down, weathering, and then they're washed away. When they're washed away into rivers, they then sort of settle down and deposited on the bottom of a lake or the bottom of the river or the bottom of the ocean. They're deposited on these layers, the oldest layers being on the bottom. Younger layers are falling on top. Once those layers all fall down, they get squished and compacted together. They get like a trash compactor. They're squished and compacted. And eventually, there are natural glues that cement them together. So we have weathering, erosion, deposition, compaction, cementation. After all that, you get yourself a sedimentary rock. The three different types of sedimentary rocks, we have clastic. Those are the ones where you can see the pieces, or even if they're small pieces, see them. Sandstone, siltstone, conglomerate, breccia. Those are all different types of clastic sedimentary rocks. They're different from each other depending on what the little pieces of sediment are. Sandstone and siltstone are different because sandstone is made from sand, siltstone is made from silt. Another type is organic. Organic sedimentary rocks come from organic things. Coal comes from the old swamps from hundreds of millions of years ago that have been squished together, and you create a very carbon-rich type of rock called coal that we can use to burn and release energy. Also, another example that we saw in class, coquina, made of old shells. It's a really cool looking rock. Kind of looks like a Rice Krispie treat of a rock. Coquina is made from the old shells of old sea organisms that all got pushed together, compacted, cemented, and created into a rock. And then you can have rocks like limestone. Sometimes it's just the chemicals. Calcium carbonate is an example for limestone that gets settled and deposited, and eventually those turn into a rock as well. So those are the three different types. And we talked about a little bit, why can we find fossils in sedimentary rock but not in other ones? Well, other types of rock, if an animal fell into a pit of magma, it wouldn't be around, it wouldn't last, it would burn up. You couldn't find a fossil in organic or in igneous rock. You also probably couldn't find a fossil, maybe once in a while, rarely, but in metamorphic rocks, all that heat and pressure can destroy a fossil. So fossils are most found in sedimentary rocks, where when the layers came down, if an organism, if like my watch was something living and then the layer came up, after a long time, my watch could become a fossil as it slowly became into a rock. That's where we find fossils. So if you want to find fossils, go look in sedimentary rocks. The last part of all this is the rock cycle. Yes, you'll need to know the rock cycle. And not just that there are three different types of rocks, but the processes that turn them into the other types. Say, for instance, if you want to make a sedimentary rock, you need sediment. So you need weathering and erosion to create the sediment to then form through compaction and cementation a sedimentary rock. If you want a metamorphic rock, the other types of rock needs to feel heat and pressure. That heat and pressure can create a metamorphic rock. If that heat is so high that the rock starts to melt, well, then it's no longer a metamorphic rock. If it melts, it turns into magma. And if that magma is lucky enough to start to cool, it will cool either inside the earth or outside the earth, and it will create an igneous rock. But notice how these processes move around. Be sure to understand the processes, not just the three different rock types and why they're different, but the three different processes. Okay. Whew. Those are our review notes. Please contact me, email me if you like, if you have questions. But again, these are good review notes to look over the notes that you already have. Use your review sheet, look over your homework, check in with me if you have questions. Good luck. It's been great. See you later.